So let's take a look at the first Linux buffer overflow here. Find the instructions here, and so for this one we're going to make 32-bit code, and I'm using a 64-bit Debian machine, although it should work pretty well on any version of Linux, and so I need this software here, which I probably already have, but I think I'll try it anyway because I have a lot of different machines and they don't all have the right stuff installed. So this is the Build Essential, gives you compilers, and GCC Multilib lets you install code from other for other processors. Like and the one I care about here is to compile 32-bit code on a 64-bit machine. All right, so let's see if I can go into 127. I do. Okay, let's see what I have here. Oh, good. This is ED 201. All right. Then I've already got the code here. All right. So what this does, let me just bring it up here. Come on. There we go. All right. This is the simplest case of a buffer overflow. So what you've got is a main routine down here, which reads text into a name field that can hold 200 characters. And then it calls the BO subroutine with name and the string date. And in this one, you have two 40-character fields, C and N, and it copies the command into C, this is the command, the second parameter, and the name into N, which is whatever name you passed in, and then it prints goodbye, printing out the name, and then it says executing command S. So this is, of course, a contrived example to show the less common type of buffer overflow, where you leak from one variable into another variable. This is not the most common situation. It's not the classic Aleph null buffer overflow, but this is in fact the one that is most difficult to prevent. And even all the modern mitigations you'll find in Windows 10 and Windows 11 cannot stop this kind of buffer overflow. So if you compile this code, and if you do it this way, you'll get a 32-bit version. Then if you run it, buff32, it asks for your name, and if your name is short, it works fine. It says goodbye Sam and executing command date. Now it also prints out the addresses where these things are stored. So you see the name is stored at 410 and the command is stored at 438, which is 28 further along, which is 40. 2 times 16 plus 8. So that would suggest that my name has to just be longer than 40. So if I do 10 characters, and I'm going to copy and paste that, 20, 30, 40, and then say ls, then it prints the name, and the way C works is it puts a null character at the end of a string to terminate it. So if I make this string longer than the expected length, it will just cheerfully continue to put storage right on top of the other string to the end. So the whole thing goes, even though it's longer than 40 characters, the whole thing goes to the name field, and the command field starts here and gets those 2 characters and executes ls. So once again, I now have command injection through this vulnerability. So you can get it running. And by the way, so once you've done that, then there's a little problem with how you might escape spaces, because spaces will terminate a word in Linux. So if I were to try to do an ls minus L the same way, by putting in this string, what's going to happen is I just get an ls because the space terminates the input string. So you have various ways to escape it to make that work. I think the one that works here is IFS. So if I put this in, and I put in $IFS for interfield separator, and then minus L, now I get an ls minus L, because the interpreter that reads the text from the user does not interpret that as the end of a string to read in, but the processor does, that executes it as a command later. All right, and so there's a remote server here running that code and some flags to find on it, and that's the simplest buffer overflow to get started with. Stop this one.